All right, we're going to have a review. And this is for adults, and it's for young people. We've studied about 11 ways. Yes, ma'am?
I don't have any paperwork. Do you have any more papers?
Do I have any more papers? There are 2 left. Can I? Derek, you need one. And I expect good penmanship.
Only one problem. That's a pen.
You don't have a pen. We have a whole table full of pens here. Does anybody need one? Okay. Thanks. All right, it's time for review. We are speaking about the physical evidence that confirms a young Earth. What is one of them? Yes, sir.
Supernovas.
Tell us about supernovas.
Supernovas are exploding stars that have lost enough gas for it to explode. And if the Earth was millions of years old, we would not see any of these supernovas. Like there wouldn't be enough stars left.
You are speaking the truth to this effect. About every how many years on the average do we have a supernova, exploding star?
25.
Every 25 years. And in our galaxy, we've found about how many?
200.
Good for you. And so if you multiply 200 by 25, you get 5,000. So we don't have enough supernovas in the solar system, not solar system, in the Milky Way, that it's going to be billions, millions of years old. Thank you. Another one? Yes, sir, Kate.
Salinity of the oceans.
Tell us about that.
So as the Earth goes through its water cycle, salt is constantly being brought into the oceans, and when that water evaporates to go back through the water cycle, it doesn't take the salt with it. So the ocean, if the Earth was millions of years old, the oceans would be much saltier.
You answer very, very well. There is not enough salt. All right. We've got young people responding beautifully.
Magnetic field.
Explain magnetic field.
The magnetic field decreases by a half-life every roughly 1,400 years.
Yeah?
And so if you decrease that half-life, we'd be much less impact than we are today.
Thank you, Adam. There is a very strong magnetic field. And if the Earth is millions of years old, there should not be a magnetic field that we could notice. Excellent.
Comments?
Tell us about comets.
Comets disintegrate quickly, and if the Earth is old, there would be comets. If the Earth is old, there would not be any comets left. Because every time it orbits the sun, it loses matter.
You're correct. The comet disintegrates each time it orbits the sun. If they've been doing that for millions of years, there should be no comets. We still have comets. Well, you've got, is that 4 already? You have to keep track for me. You got another one?
Galaxies.
How about galaxies? How do they show we're living in a young universe?
Mainly the spiral galaxies, but the stars are winding up. So if the Earth was millions of years old, there wouldn't be any spiral galaxies.
I love your answer. Galaxies are winding up. And if the world was billions of years old, they would be wound up. They're not. Excellent answer. Is that 5? Nikki? No.
Ocean floors.
Explain that.
There's not enough
Excellent. Every year, the ocean is silt is going into the ocean. There's not enough silt for it to be millions of years old. That's 6. Nikki, explain that.
Very quickly 1 year.
Engineers, right?
Very quickly 1 year, as opposed to taking millions of years to form, having very quickly, overnight, I think, right?
Thank you. Thank you. Thank you. Anybody else? Is that hand up, Ivan?
No, it's not.
Katie,
The rock stratifolds.
what are those?
They're folds in the rock layers that were folded down, and they're folded together while the rock was still somewhat soft. But according to an evolutionist, each rock strata took millions of years to form, then they wouldn't have folded, they would have cracked. So you just see a bunch of jagged cracks, but they have nice folds in them.
That's right. These rock layers are the same age, and they were folded after they were laid down while they are soft. Today they're hard, but they're not cracked.
Dinosaur stratas, when they get covered up so fast by the flood, everything is perfect, all the detail is, while the evolutionists think that, it will probably be covered up quickly by a regular flood, a local flood. Scientists found places like on Mount Everest where they found dinosaurs, bones.
We find fossils on the mountaintops. Yeah. I like all of your answers, and so we've got them all. I believe the ocean floor has to do with the silt, the ocean salt, magnetic field, the rock strata folds. They are not broken. We have strata surfaces. There's no erosion. There's no debris between these rock surfaces. And so they had to be laid down rather quickly at the same time. Polystrate fossils. And that's where you have the tree fossilized between layers of rock. And that tree could not have fossilized over millions of years. It would have deteriorated. So polystrate fossils give the idea that rock layers are all the same age. And Mount St. Helens, where you have a huge canyon formed very, very quickly. All right. There are fossils. We're now going to go to Stone Age skeletons. What do you know about the Stone Age? Had you been paying attention? How long was the Stone Age? All you know is from the Flintstones, right? This is considered a Stone Age skeleton. It is fossilized. Evolutionary anthropologists, I want you all to know anthropologists study man's history, claim man was living 185,000 years before agriculture began. And they claim in a constant world population of from 1 to 10 million. So for 185,000 years, you have people dying, and there are from 1 to 10 million people on the earth constantly. They are being born at the rate they are dying. And so there should be quite a few Stone Age skeletons. All that time they were burying their dead, often with artifacts. Artifacts would be tools, jewelry, things that would be meaningful to them. If this is true, they would have buried at least 8 billion bodies if there was a Stone Age. And if it was 185,000 years. And so if you want to copy that, you certainly may. It will be in a handout. By the way, we have the handout for lesson 3. We will make those available at the end of the class, all right? So, the problem that we have is this. We have found only a few thousand skeletons which could be Stone Age. So we believe this implies that the Stone Age was much shorter than some anthropologists think, because there's 185,000 years that they want to say man lived the Stone Age. It's before agriculture. And so number 12, in real simple terms, is that there are not enough Stone Age skeletons. We can't find them. So if people have been dying for 185,000 years, we don't have the evidence, the physical evidence. Joe?
Us young earthers, do we even ascribe to a Stone Age?
There would be a time in Stone Ages when they used stone tools, would be the only thing. And I'm not sure we ascribe to a Stone Age. John?
And I would lean towards not ascribing to a Stone Age because it implies many other things besides just stone tools, like music and things like that we see in Genesis, right? And I think in the genealogies it talks about those making things out of iron and bronze and musical instruments and things like that, all in the first, before the flood.
Thank you, John. What John is saying is that we don't subscribe to a Stone Age because it ascribes to man. I want to summarize what you said and maybe embellish it a little bit. But he's saying, when you look at Genesis, what is it? 3 generations from Adam? 4 generations from Adam? You have musical instruments. You have iron. You have bronze. And that happens rather quickly in the history of mankind. Adam and Eve are not what you would call Neanderthal people. The beginning of man, an evolutionary model, means man was very primitive. He grunted at his wife, and they later on developed some kind of a language, and they began to try to figure things out over thousands of years. That's not true. Adam is created with language. And when you study language itself, that's really complex because it's more than vocabulary. It has to be associated with a lot of cognitive things. And so when God speaks to Adam, and what was the first assignment Adam had? Do you remember? Name the animals. When did he do that? What day? Day 6, before God creates Eve. Adam named the animals. Well, God presented the animals to Adam. The animals recognize Adam as their king, as their Lord, as their ruler. And when Adam names them, he doesn't just say elephant, giraffe, lion. He is describing their character. The closest we come to that today would be the scientific name that we have for animals. And those scientific names describe the animal. And so God presents those to Adam, but he does that on day 6, right after his creation. Because Adam was to see he did not come from the monkey world. There was no animal fit to be Adam's helper. Now, they could be his friend. There's the dog world out there. But you have here Adam realizing that I am of different kind than the animal world. But Adam had a keen mind, a quick mind. And so the Stone Age implies that early man was very primitive and very, well, he's Neanderthal style. That's not true. Adam was very intelligent. And his descendants are able to discover by God's design how to make musical instruments, how to make iron and bronze. Thank you, John. That's very helpful for us. Does that help you, Joe?
Yes, well, that's what I figured.
Thank you.
But I just,
Wanted some more confirmation on that. Okay. I appreciate questions. So we have biological tissue. Bio, life. Biological is the adjective. Tissue. Your and my bodies are made of biological tissue. It might surprise you, but maybe you know this is what we think a Tyrannosaurus Rex looked like. But these are actual photographs. 2005 is the year. 2005, tissue fragments from a Tyrannosaurus Rex femur, leg bone, are shown in photo A to be flexible and resilient, which means you can pull on it and it'll snap back in place. This is found in the bone of a Tyrannosaurus Rex because they had to cut the bone in order to ship it. And when they cut the bone, this is what's inside the bone. Now, according to the evolutionary model, how many years ago did the dinosaurs die off?
A couple billion?
Little less than that, 63 million years ago. Now, could you have tissue like that? That's 63 million years old. It's not possible. When stretched, arrow, it's where they're stretching it, right here. When stretched, they return to their original shape. So that tells you this is still quite recent tissue. Photo B shows the tissue after it has been air dried. Photo C shows regions of bone having fibrous character, which would be dinosaur meat. Maybe we could, have a dinner some night here with dinosaur meat on the bone. Wouldn't that be great? We don't see this in a fossil. This is 2005. This was found in Montana. This is it under a microscope. This tissue is still flexible, still resilient. There it is. And if you want to look at this on your own, it's youtube.com. That's it. I will try to put this in the handout, but you can Google this and you're going to find it on YouTube. (2014), something similar. We found other recent tissue. This is the guy that found it. And so, that was from a Triceratops skeleton, that it was in the bone. And so this is what we think a Triceratops looked like. But this should be number 13, or is it 12? It is 12? 13? I am wrong. Biological material decays too fast for the dinosaurs to have died off millions, and they were dying off billions of years ago too, because they lived in a long expanse. But the last dinosaur, according to the evolutionary model, this cannot be 63 million years old. Yeah, it's supposed to be 13, my mistake. Carbon-14 is number 14. Now, you don't need to understand everything about carbon-14 to understand what's going on. Carbon-14 is a way that we have been measuring the age of biological material, like bones, fossils. And the reason that we believed, I think this is changing a lot in the scientific world, that this has come under quite a bit of criticism recently. But here's what they say. Carbon dating is a way of telling the age of a once living thing by measuring the amount of carbon inside of it. You and I, all living things, are taking in carbon. There's carbon-12, there's carbon-14. Carbon-14 is unstable. It's a type of carbon called carbon-14. It decays after an organism dies. So at the time of death, that organism's body contains a certain amount of carbon-14, but as the years progress, it loses carbon-14. So by measuring how much of it is remaining in a dead organism, scientists can figure out how old the organism is. That is the theory. That's the hypothesis. Caden.
But the problem is you don't know how much it had to begin with.
We don't know how much it had to begin with. You nailed it. You nailed it. We're going to get deeper into that when we talk about dating methods. That's our next class, I think. Thank you, Caden. That's a great thing to say. So this is a little bit out of focus, so don't think your eyes are going batty. But this really shows C14 in bone at the time of death. Well, the amount of C14 becomes less with time, and so we believe that this bone here only has this much in it, and so we come to some idea how old it is. But Caden, you blew it full of holes. If we don't know how much carbon-14 it possessed at the time of death, how can we assume that we know how old it is by looking at the carbon-14 we have now? Maybe I could ask you this, Derek.
Well, not only that, but how long has carbon dating been around? Do you know the answer to that?
I'm going to refer that to John. Can you answer that,
I
John?
don't know right off. It's been around for a while,
But it's not 100 years or something.
Like, okay, so not even 100 years, so they're measuring the rate of how carbon's decreasing in the last, let's say, 100 years. How do we know that the rate at which it's been decreasing in the last 100 years is the same as the rate it's been decreasing for the last 1,000 years or, quote, million, billion years?
Thank you. Thank you. Thank you. I think there's a half-life of carbon-14, and that is something they use for that. I don't expect you all to see this, are not the words, but living organisms absorb carbon-14, it's radiocarbon, during their lifetime. Then it becomes a fossil over here. They take a piece of the fossil, is burned and converted to carbon dioxide gas, and then they can collect the molecules of stable carbon-12, unstable carbon-14 that is given off, and they can measure how much carbon-14 is in there. But the problem is, what you have said, Derek, and what Caden has said, there is really not enough information here. We know that stone and so on was brought to the lab to be tested, carbon-14 from Mount St. Helens, and they conclude that it's 150,000 years old. And we know it was just formed there. So they're backing off of this sum. If we began with 1 gram of carbon-14, after 5,730 years, we would have a half a gram. Its half-life is 5,730 years. And so you would have that, and then another 5,730 years, which would be 11,460 years, you'd only have 25 hundredths of a gram left. Well, you can see that we're not going to get into millions of years. The next one is going to be 17,000. And so the issue is, and I don't think I need to show you that, it just will confuse you. But here, with their short 5,700 year half-life, no carbon-14 atom should exist in any carbon older than 250,000 years. There should be no carbon-14 left. It should all have decayed. We still have it. Yet all known strata contain significant amounts of carbon-14, even though such strata are supposed to be millions or billions of years old. If it's there, how can it be that old? Because its half-life would reduce it to such a small amount, we wouldn't be able to notice it. Is that helpful to you? So, in so many words, this should be number 14. These will all be one off. Too much carbon-14 remains in deep geologic strata. Just because there's carbon-14 is the evidence that we live in a young universe. Young Earth. Thank you, all of you, for your comments. Yes?
They started carbon dating in 1946.
1940?
6.
Thank you. Thank you. Trees. How do trees reveal a young earth? Yes, sir.
Because they rot so fast when they fall down to the ground and they lose their roots from the ground, they'll start decaying, and they decay too fast for it to be billions of years. Otherwise, we would find fossils of it.
I love your answer, but what if I ask you about living trees? Living trees are evidence we live in a young earth. Caden.
I'm just gonna guess that we don't see any trees that have enough rings to be old enough to be older than 6,000 years.
You should be teaching this class, I think. This is wonderful. This is the oldest tree on the earth, we believe. It's in California. His name is Methuselah. Methuselah, the oldest known bristlecone pine. We used to think the sequoias were the oldest trees, but we now believe the bristlecone pine tree is the oldest kind of tree. A bristlecone pine can refer to one of 3 species of pine trees. The oldest bristlecone pine, Methuselah, is about 5,000 years old and is the oldest known individual of any species of tree. Now you're going to ask this question, how do they know it's 5,000 years old? How could we figure that out?
It's switch. I'll take it back.
Does somebody have a good answer? Caden?
They took a tree core sample where they drilled down to the center of the tree, pulled it out, and then you can count each individual row.
That is a possibility. They've also cut down others that are similar to this. And counting the rings, this tree is 5,000, in the neighborhood of 5,000 years old. Now, why are there no trees older than 5,000 years when the plant world has been here for millions of years? Yes.
What, the flood?
The flood. The flood was about 5,000 years ago. Some trees could have floated on the water of the flood. You know, when you and I look at pictures of the flood and Noah's Ark, we don't see any debris on the water. What would the flood waters have looked like had Noah been able to look out of the ark? What would he have seen? Yes, sir.
Debris of trees and stuff like that, things that float. Like at Mount St. Helens, they found lots of trees just floating above the water, and then finally, when it had enough water in it, it sank.
You are good. You'd see dead animals floating around. What color would the water be?
Brown.
Brown, like flood waters. And so it is possible that trees were uprooted, trees floated, and when the water went down, that these trees took root again. That is possible. So we could have some trees that are maybe older than the flood. But we don't have any tree that's millions of years old. The oldest tree that we have is 5,000 years old. And if the trees have been here for millions of years, there's no evidence for it. So, Methuselah, the oldest known bristlecone pine. Number 15, the oldest trees are only 5,000 years old. So there would have to be a young earth. History. You all love history, right?
Yes.
When's the best time to study history? Morning or afternoon?
Afternoon.
Why?
Because you're more awake.
I thought it'd be in the morning before anything else happens, right?
Yeah.
The oldest known world map is the Babylonian map of the world known as the Imago Mundi, created during the 6th century before Christ. This is a picture of the oldest world map. 6th century before Christ, about how many years ago?
8,000.
2,600 years ago. I have several pictures here to show you. The earliest known wooden ship, 2,613 BC is what they think. How many years ago is that?
4,500?
About 4,600-year-old ship. See, there's some debate whether Noah could have built a ship, but we're finding them. The earliest records of Egypt, 3,100 BC. How many years ago? About 5,000. The Egyptian pyramids, they were rebuilt from 2,630 BC to 2,611 BC. That's always confusing because the numbers go down as you come towards the birth of Christ. And so here you have about 4,600 years ago. Man was building pyramids. This is Rachel's tomb. She died around 1,800 BC. The Great Wall, China, built around 206 BC. The Colosseum in Rome, 70 to 80 AD after Christ's birth. Mayan, those are the Indians, Native Americans that lived in present-day Mexico, the Yucatan Peninsula. The Mayan Observatory built around 1000 AD. This Cambodian temple, and by the way, this is real near the orphanage. Siem Reap is the city where the orphanage is, and you can take a bus and get to this temple in a half hour. It's just very near, and that's why Siem Reap has so many tourists, although that has stopped with the COVID. This Cambodian temple built during the 12th century, so it's about 900 years old. How do these all confirm we live in a young earth?
The dates they have for them.
Okay. You're speaking well.
None of them are older than like 6,000 years.
That's true. Man has no history beyond 6,000 years. China, one of the oldest countries, she considers herself around 5,000 years old. Egypt considers herself around 5,000 years old. Korea also is a very old country, but there is no country that is older than 5,000 years old. That doesn't surprise you. Why not?
Because we believe in the biblical timetable.
That's right. These countries were formed at the time of the Tower of Babel. And so here's China saying 5,000 now, we're about 5,000 years old. That fits perfectly with the Tower of Babel, with the flood. So according to evolutionists, prehistoric men, prehistoric means before they started writing records. Prehistoric man was living 190,000 years ago. He built very large monuments, made beautiful cave paintings, and kept records of the phases of the moon. Why did he wait 180,000 years to start recording history? Our earliest known written records were written from 4,000 to 5,000 years ago. That's the earliest records we have. So, is it number 16? History is too short. We can't be living in a old earth. I'm going to skip some of this right here, if you don't mind, because this is all review. And I want to go to the next part of your, here's number 7. Is that number 7 on your handout? What arguments are used to support the earth is millions or billions of years old? I'm giving you arguments. I'm not giving you facts. The evolutionist is going to say the fossil record. Now, you and I have shot holes through the fossil record, but you should be aware that people are going to say, well, look, we know these fossils are millions of years old. We know they're millions of years old because look how long it takes for the sediment to fill up on the ocean floor. So the fossil record, with all its death, mutations means there is change in the species. It's not a change from, in the kind, it's not a change from cats to dogs, but mutations means there are changes in the kind, and we Christians agree with that. Look at the human race. Look at the different color skins we have and the different hair colors and eye colors. There is mutation, but that's not evolution. Mutation is a loss of information. Evolution requires a gain of information. With a disease, with the suffering, bloodshed, and violence, they say, well, this has to be millions of years. But you can challenge them on fossils, right? What are you going to say to them?
There aren't enough fossils.
Okay?
There's no transitional fossils.
No transitional fossils, where you see something that's halfway between this kind and that kind. And also, as we said, fossils are formed very quickly. They need to be covered immediately with slime, some very watery kind of substance, so that you get all the detail and that it cannot be exposed to oxygen, and that would have happened during the flood. Number two, they're going to say rocks. Slow, gradual processes forming rocks. Well, we're going to study rocks in this course. We're going to find out that rocks form very quickly. They do not take millions of years to form. All right. Number three, this is a lot to write, but this goes back to this carbon-14 radioactive dating, and we just challenged that, but they stand, although this is becoming a weaker argument, that they want to use radioactive dating and say, well, we know how old these are because these fossils are in these rock layers, and these rock layers contain these fossils. And so you have some way to counteract radioactive dating. What's one of them? You were talking about the carbon-14 content. We don't know how much carbon-14 this organism had when it died. We can measure it now, but we can't go back and find out how much carbon-14 was in it when it passed away. And so that's the problem with radioactive dating. But this is going to be an argument that they're going to use. Let's see. So they're talking about rocks and rock layers. And how do you know, just a little review, how do you know that these rock layers are all laid down rather quickly on top of each other? Caden?
There's no erosion in between each layer.
That's right. There's no erosion, there's no debris here whatsoever. But they're going to try to tell you these are millions of years between these rock formations, because they're looking at how long it takes to lay down a layer of rock today by the slow processes we see today. Well, we believe these were laid down by the flood with the tsunamis and with the volcanoes that were taking place. Aren't these just beautiful? But you see, there's a different kind of substance here, silt, that were laid down, and it washes this way, and it washes this way, it washes back, and you get these different layers forming very, very quickly. Fossils, they're going to talk about fossils, but these fossils had to be covered up very, very quickly. And so these are not millions of years old. These happened in a very short time. These needed to be covered up immediately to get all the detail that we have in these fossils. Carbon-14 dating they're going to use that is a reason to believe that the Earth is old. We've talked about that. And we have canyons. How do you know canyons do not prove an old Earth?
Mount St. Helens.
Mount St. Helens is enough. And how about, okay, here we go. See, I love pictures. This is the Grand Canyon. That's the evolutionist's little treasure. But you can say that was all washed out right after the flood. This is in China. Isn't that beautiful? And then you have mountains. How are mountains formed? When were they formed? Maybe that's a good question. Caden?
Tectonic shifts during the flood.
During the flood, yeah. And so these tectonic, he's talking about the plates of the earth, they smash together very quickly and they form these mountains. Today these mountains are growing. I think Mount Everest, which this is a picture of, Mount Everest is growing, I think, 1 centimeter a year. 1 centimeter is a little less than an inch. Well, if it's been doing that at that uniform rate, then we're living in a very old earth. But you've got the flood. Yes?
Are you saying there may not have been mountains before the flood?
There were mountains before the flood. But the mountains that we have today are not the mountains that were there before the flood. Yes.
And if you look at the Mount Everest, would it be in the atmosphere so it was like that?
Yeah, it's way up in the atmosphere here. And by the way, we're finding fossils up in this region, which means it once was on the ocean floor, once covered with water. John?
Can you go back to your Grand Canyon picture?
I think so.
There was something I learned a few years ago at the Grand Canyon, right? So the evolutionist says that the Grand Canyon was formed by the Colorado River slowly eroding away over the years to get to where it's at now. If you look at the surface there,
Here.
right up there, what would have been eroded away before it was eroded away? It would have been a dome. So the Colorado River would have had to come in, flow uphill, and then over that dome to start eroding that away.
Thank you, John. Thank you. Really appreciate you. I want to finish this up, and I don't want to keep you long. And so all of these were formed very, very quickly, we believe. So what supports it that is young? Let's see. That's it. Remember this cow? What color is it? And now it's red. Why?
Worldview.
Your worldview. You're looking through red glasses. Now you're looking through your green glasses. Same way with all of how you and I see the world. If I'm biblical, I'm looking at it through biblical glasses. The evidence is the earth is young. If you're an evolutionist, you're going to look at it through your evolutionary glasses and come up with another thing. So we will meet next week. There'll be a new lesson next week. I think it's on dating. Am I right on that? I don't have the syllabus in front of me. But we will follow that syllabus. And then I will be sending you another thing to copy, Ivan. All right? Thank you. And here are, and we're going to close in prayer, these are lesson 3 handouts. Okay? Thank you, Ivan, for printing those out. Really appreciate it so much. And thank you for all of you for being here. I really respect you folks, love you folks. Let us pray. Our Father, thank you for this wonderful time together. May you give us wisdom and understanding so that we give the reason for the hope that is in us. In Jesus' name, amen.